Alright guys, so this is the first video, well the second video for radicals, but this one we are going to be combining radicals by addition or subtraction, okay? And basically, I'm going to start off with a problem you guys should all be able to do. So it's 7x plus 2y plus 3x minus 6y, okay? So now, the way we all do this, as everyone knows, is you have to combine like terms. So what I mean by like terms is what numbers have the same variable. So we have 7x's, we have 3x's. Combine them, we get 10x's. 2y's, negative 6y. Combine them, we get negative 4y. So, simple as that, 10x minus 4y. If you can do that, you can add or subtract radicals in a nutshell. So, let's take a look. We have 3 radical 2 minus 5 radical 2 plus 5 radical 3. Okay. When you're simplifying radicals, you want to make sure that each radical, aka the square root of 2, square root of 2, square root of 3, cannot be simplified anymore. And in this case, they can't. So that's the hard part, really, because if you can simplify them, it's a little bit of work. But we did that in the last video, so it shouldn't be that hard. So now we got to look is everything that has a radical 2, we can combine their outsides. So we have a 3, negative 5. Gives us negative 2, radical 2. Treat the radical 2 like an x. Do not subtract 2 and 2 to get 0. Leave it. Okay. Then we have a 5 radical 3. Since there's no other radical 3's in our expression, it's just 5 radical 3. Okay. I'll do another one. We have 4 radical 5 plus 6 radical 7 minus 3 radical 5 plus 5 radical 7. Okay. Again, let's treat them like variables. So we have a radical 5 here, radical 7, radical 5, radical 7. None of them can be simplified, so now we just have to combine. So if we look here, radical 5, where else do we see a radical 5? Ooh, right here. So you have a 4 radical 5 minus a 3 radical 5, just gives us a 1 radical 5. We don't write the 1 because it's a coefficient, or it's just a placeholder. Then we have radical 7, 6 plus 5 gives us 11 radical 7. And that's your final answer. Okay, so those are the easy type. Now on to a little more difficult one. We have 3 radical 18 plus, 2 radical 48 plus radical 12. Okay. Now, if we look back, the difference between this problem and the last two is that if you look here, all of the radicals are simplified. There's no simplification to be done. But if you look here, these radicals are not simplified. So first we must do that. So we can take 3 radical. We can simplify 18 to become 9 times 2 plus 2 radical 16 times 3 plus radical 4 times 3. Okay, so I just broke them down into their factors that contain the largest perfect square. So 9 and 2, the 9 can come out, the 16 comes out, and the 4 comes out. So the only tricky thing here is there's already a 3 out front of our radical symbol. So it's 3 multiplied by this radical. So when the 9 comes out and becomes a 3, it becomes 3 times 3 radical 2, because the 2 is left over. Likewise here, the 2 is being multiplied by the radical. So when the 16 comes out and turns into a 4, it becomes 2 times 4 radical 3, because there's a 3 left over. Plus 2 radical 3. Because when the 4 comes out, it turns into a 2 because you take the square root of it. So then we get 9 radical 2 plus 8 radical 3 plus 2 radical 3. Okay? The only thing left to do now that all our radicals are simplified, combine whatever radicals share the same number inside. So there's a 2 here, but no other 2's, so we can just have 9 radical 2. Then we have an 8 radical 3, a 2 radical 3 gives us a 10 radical 3. And that's it. That's your answer. 9 radical 2 plus 10 radical 3. Okay. Let's just try another one. We can have 3 radical 45. Actually, I don't like the 3. I'm going to change it. Let's change that to 5. So 5 radical 45 plus 2 square root of 16 plus, I don't know, let's see, 4 square root of 100. Actually, let's not do 100 because that's easy. Let's do square root of 300. See, this is why you should take notes, or I should make notes before I do this, but I'm trying to wing it. So we have 5 radical 9 times 5, because 45 factors to 9 and 5. Those are the largest ones we can do. Plus 2. Actually, it's nice because the square root of 16 just becomes a 4, because it's a perfect square. Plus 4 square root of 100 times 3. So you can pull out a 9, pull out a 10. I mean, pull out a 100. So this becomes 5 times 3 radical 5 plus 8, because 2 times 4 is 8, plus 4 times 10 radical 3. Okay. Now when we go back, we're going to get, let's see, 15 radical 5 plus 8 plus 40 radical 3. Okay. So if we look now, if we notice, I don't like the way this 5 looks. For some reason. Okay. If we look now, we notice that none of the radicals share a common number. So this is your final answer. 15 radical 5 plus 8 plus 40 radical 3. Okay. So that's the video on adding and subtracting radicals. Next up, I'll do multiplication.